Hello and welcome, my dear students, to my channel Mathematics Made Easy. This is Mr. Chika welcoming you to today's session. This session is on the special request of my grade 10 elite students, which is on Chapter 7, Lesson 4, Operation with Matrices. So the learning objectives of this video would be you will learn how to perform algebraic operations with matrices, and today we are going to talk about the two major simplest algebraic operations or mathematical operations, which are addition and subtraction of matrices. So if you are liking my video, watching my video, humble request to please subscribe to the channel. Make sure you hit that bell icon so that you receive notification of all my upcoming videos. Now let's dive into today's session and learn how do we do addition, subtraction of matrices. So the first question that we are taking here is on analyzing data with matrices. This is from page 27 of your Elite Math book. So let's discuss. The manager at the Dubai location would like to use this matrix to further analyze the representatives. So here in this kind of a question, the matrices will be already given to you. You need to just analyze the data or information which is given in that matrix using the operations of addition and if need be subtraction. So here we are going to use addition. Four parts of this of this word problem. A part says add the elements in each column and interpret the result. So let's look at the matrix first. So the first column of the matrices shows the wages and the second column shows the salaries. Then there are three kinds of representatives. One is entry level, another is assistant, and the another is associate. So first you need to add the elements of each row. So there are two columns, C1, C2. So we'll add all the entries or numbers in C1. If you add them up, this comes around for the first column 9 this 0 6,000. Okay, so the sum of the first column is 6,000. This is representing the total average daily wages of the three types of employees. So the wages of entry employee is 900, the wages of assistant is this much, and associate is this much. So the total, if you add them up, comes out to be for all the three types of employees the daily wage. So that is 3,000. Let's do similarly the sum of all the salaries. That is the column 2. So 0, 0, 0. Then again you have 0 here followed by 9, 10, 16 and 6 again. So this is 6,60,000. That's the sum of the second column and it is representing the total average annual sales of the employees. So this is wages column 1, this is sales column 2. So you've got the addition. Now in B part, the manager wants to determine the average wages for all employees at the Dubai location. He decides to divide the total of the first column by 3, the number of the three different positions, what is the average. So very well, I hope you remember that average if you want to calculate is the sum divided by the number. So here there are three types of representative, entry, assistant and associate. So we are going to divide by 3 and the sum of all wages has already come out in part A as 6,000. So 2,000 is the average wage for all employees at this Dubai location. Now, is this average accurate? You have to explain and you have to check your answer. So now, if there are same number of each type of representative, means what? If the entry, assistant and associate, all these three types of different representative are equal in number, same number of these type of representative, then the average is accurate. So if there is more than one type of representative than others, then the average is not accurate and would need to be weighed accordingly. So what does this mean? This point is very important for reasoning, for justification. It says that this average 2000 which you got in part B is accurate average if the number of entry, assistant and associate employees are very close, they are same in number. However, if say for example entry is 5,000 employees, assistant is only 1,000, associate is maybe 3000. So if there is a disparity, if the number of the type of representative among these three is not balanced, the number is different, then the average will not be that accurate. So accordingly, you need to look at how much weightage is given to each of them and then calculate your average. So this is an important point. Last one, would you add the rows to provide any meaningful data for the manager? So if you look at the first row represents what? It represents the wages, 900 of the entry representative, and the sales made by him. So if you add that, it doesn't give you any beneficial information, no meaningful data. So no would be the answer, because the sum of the row indicates the two different forms of data, number one wages and number one sales. However, if you add column wise as you did in part A, it gave you the useful information about the first column, the being the average total daily wages of all three, and column 2, when you added, you got the total average annual sales for each type of employee. So in this kind of a matrix, if we analyze it, we see that adding the columns gives us beneficial, meaningful data. However, adding the rows does not provide any meaningful information. So that's how you do the analyzation in detail for a given matrix using the operation of addition. Now I'm taking a guided practice question again from the same page 27. Let's see what information is given here. So you are given a table. This table displays the Latino population in the US in millions. So this is the US population census data. First step, you have to organize the data that's given in this table into a matrix. So let's see what are the categories. So first category is the age. So if it is 0 to 19, this is the number. If it is 29 to 39 20 to 39 years, male and female, this is the information, and so on. The first column represents the male categories, the second column represents the female categories. Similarly, R1, R2, R3, R4. So if I'm going to take up my matrix from here, just I'm taking the numbers. So your answer of A, where you organize the data in matrix. So this is 1, 2, 3, 4, 4 rows, 2 columns. So 4 cross 2, or it will have these 8 elements. So that's how you organize, and I hope from my previous videos you were able to recall that when you put a matrix, you put these big square brackets. Let's begin by writing the first column. So 7.1, below is 6.8, below is 3.2, and 1.1. That completes first column with 4 rows. Now 6.6, next column, 5.9, 2.2, and 1.4. So that completes a part. Now add the elements in the columns and interpret the result. So this is my first column, this is my second column. Let's add them one by one. So first I'm adding my column 1, and then we are going to do the similar thing for column 2. So let's add them and interpret the results. Okay, so 7.1 plus 6.8 plus 3.2 plus 1.1. That's your column 1. So this whole thing, when I add it vertically, comes out to be 18.2. Let's do a similar process for the second column. So 6.6 plus 5.9 plus 2.2 plus 1.4. So that comes out to be 16.1. So we have done the addition part in the columns. Let's interpret the result. So what is the result saying? It is saying that for age group 0 to 60, because we're taking all the rows and adding them up, the average number of males are 18.2. So I'm writing here average number of males is 18.2, and the unit is, not to forget, in millions we are talking about. Similarly, from the second column, which was representing the females, the average number of females in this US population is 16.1 million. So that's the useful information you get by adding. So that completes B part. Now C part, add the elements in the row and interpret the result. So now if I do a similar process, I would encourage you to try it yourself. You add for R1, R2, R3, R4, and then after you finish adding, you'll interpret the result. So when I do for the first row, it is 7.1 plus 6.6. Then for row 2, we come here 6.8 plus 5.9. Similarly, 3.2 plus 2.2. 1.1 plus 1.4. So this comes out to be 0.7, 14, 14.7. This comes out to be 17, 12, okay, 4.5, 0.52. Okay, so this is the information. Now let's interpret. So R1, when you add, what is it representing? It is representing the total male plus female population, right? And within the age group of this. So this is the total female plus male population, and it is referring to this specific group 0 to 19. Similarly, this is representing the total males and female in the age group 20 to 39, 40 to 59, and 60 plus. So again, this is giving us useful information when we add the elements in the rows. D. Would you find the average of the rows or the columns to provide meaningful data? Okay, now let's look. If we already have added the rows and columns. If we look at the columns first, let's look at columns. So if we are to find the average of the columns, means the average of 18.4, so we divide it by 4, so that would give us in D part, the average of the column would give us the total number of average males in the age group 0 to 60 plus in US population. So yes, that's a useful information. Similarly, for the second column, you will get the average number of females. So this 16.1 which you got added, you divide by 4, and that would give you the average number of females. So again, it's a useful information when we do it column wise, the average. However, if we look at rows, row was what? The total male and female for the first row. So for this, there is no useful information that you get. If you get the total as 14.7, there is no average that is, giving any information which is useful. So if I were to make a choice, if I have the option of taking average or rows or column, then the one that gives me more meaningful data is coming from the column. So I would take and go ahead with average of the columns. So that's how you do the question. I hope you understood it well. If you have any questions or queries, put it in the comment section and check your answer. Now we begin with the simplest algebraic operations, which is addition and subtraction of matrices. So now I'm going to give you the key concept. It says to add and subtract two matrices with the same dimension. Same dimension means same order. The number of rows and number of columns have to be same. However, the elements at each position could be different. You add and subtract their corresponding elements. Corresponding means they have the same position in the matrices. So for example, if I have this 2 cross 2 matrix A and B and I want to add them both, then the result will also be a 2 cross 2 order matrix having 4 elements 1, 2, 3, 4, and to get its element you're adding the corresponding. So if I take the first element in the first row first column, I add it with the first row first column element of the second matrix. Similarly, B with F, C with G, and D with H. So the order, the position is very important. The only thing that will change in subtraction would be that instead of plus, there will be a negative sign. However, again, you are subtracting in the corresponding way, taking the elements in the correct order. You can have this example. So 3 plus 2 gives you 5. Minus 5 plus 0 gives you the same. 1 plus minus 9 gives you minus 8. 7 plus 10 gives you 17. So this is a very, very simple operation where you just add or subtract the corresponding element. Okay, so let's solve some questions now. These are some unsolved guided practice questions. I've taken them from your math book and they are given on page number 28. So let's solve them. Let's look at the first part. Here first you will notice you have to do subtraction, and in order to do subtraction of these two matrices effectively, we have to check their order. Okay, so 2 rows, 2 columns, it's a 2 cross 2. 2 rows, 2 column, it's a 2 cross 2. So dimensions are same, so definitely we can do the subtraction easily. Again, the result will also be a 2 cross 2 matrix. So 1, 2, 3, 4. 4 elements will be there. Let's try and fill them up now. So the first element here and the first element here will be subtracted. So -3 and -4, and in between there is a subtraction. That's the first element. Next, 4 with 12, there's a subtraction. So 4 minus 12. Next, minus 9 with 8. So minus 9 with 8, and there is subtraction. So don't make sign mistake. That's the only thing you need to be careful of. -5 and -7. And there is a negative sign in between. So this is how you get it. Okay, so just simplify. -3 plus 4. 4 minus 12 is minus 8. Here you have minus 17, and here negative becomes plus 7. So the final answer you will receive here for the matrix is as follows. So that's your result for A part, where you have done subtraction, or you subtracted two matrices of the same order, 2 cross 2. Let's come to 2b. Let's do addition now. Again, 2 rows, 3 columns, 2 cross 3, 2 rows, 3 columns, 2 cross 3. So well defined. We can easily add. Let's add them. Minus 9 will combine with the corresponding element, plus of minus 4. 8 will combine with the element with it, 8 plus of minus 3. 3 will combine with 6. That's your row 1 complete. -2 combined with -9. 4 combined with -5. So I hope you are able to observe how I'm taking the corresponding elements. -7 combined with 18. Now this is pure arithmetic calculation. So minus of minus will give you negative sign. Again, negative 8 plus of minus 3, that's 5, minus 1, 9, and 11. So that's your answer. So here you saw how you are going to do addition of two matrices. So one part we have done. Let's look at the last one, C part. Now here there are 3 rows and 2 columns. So 3 cross 2. And in the second one, there are 2 rows, 3 columns. So is the order same? No, not at all. So how can you even subtract? So this question, the subtraction is not possible. The reason is the order is different. There are no corresponding elements that we can add or subtract. So you cannot do any sort of calculation here. Let's now move on to simple scalar multiplication. Here each element will be multiplied with the each element of the matrix will be multiplied with that scalar. So if you have any constant, any number which the matrix is being multiplied to, and when you do this, you multiply each individual element by the value of the scalar. This operation is called scalar multiplication. So for example, you have a matrix A, B, C, D, and you try to multiply with the constant K. You multiply, the rule says, each element inside that matrix with that K. So the inside, this K goes and gets multiplied to each element. Let's take an example. If you have k as -3, this is the constant, the number, the value which is given, and you have the matrix 2 cross 2 with these 4 elements. Then after multiplication, this -3 gets multiplied to each element inside. So -3 times 4 gives you -12, -3 multiplied with 7 gives you -21, and -3 and 6, so on. So multiplication by a scalar simply means multiplying each element of the matrix with that number which is given as the scalar k. Now I'm showing you some properties of matrix operation which are very useful while solving questions on the same. So for any matrix A, B and C, if you are given three matrices in which the matrix sum and product are well defined for any scalar k, then the following properties 1, 2, 3, 4 are always true. The first is commutative property of addition. So it means that if you have two matrices A and B and you're trying to add them, then A plus B is same as B plus A. So changing the matrix order does not change your addition result. That's the first property. Associative property of addition, if you have three matrices and you first add A plus B in that order and then you add to the result C matrix, or if you first add B and C matrix and then add A. So the grouping, if it is different and then you're adding the third matrix, the result will still be the same when it comes to addition. Then is your left scalar and right scalar. So simply when you are multiplying with the scalar k in the left direction, k multiplied with a plus b and giving you ka plus kb, that's left scalar. Right scalar when you have a plus b multiplied with k coming from the right side. Again the result is same, ka plus kb. These properties will be very helpful when you are performing multi-step operations on matrices, and in the next slide I'm going to give you an example of the same, how these properties can be applied in order to give us the solutions for multi-step operations. Okay, so let's solve this question on multiple operations for matrices. So we are given two matrices A and B. Let's first write the order. So 3 rows, 2 columns, 3 cross 2. It must be having 6 elements, which is quite evident. Same for the matrix B. So both have the same order. Now we need to find in this question minus 6 times B matrix plus 7 times A matrix. And then we are going to be adding the two. So let's do that one by one. So this is same as 7a minus 6b. So I'm first going to find 7 times a, then I'm going to find 6 times b, and finally I'm going to subtract the two matrix. So that's one way of doing. The other way that would also give us the same answer would be to find minus 6b matrix, 7 times A matrix, and then add the 2. Okay, so both are going to give us the same one. So let's calculate the scalar multiple 7 times of A. So 7 times, let's write the same matrix, minus 5, 6, 2, 3 minus 8, 9. So the rule of scalar multiplication says that each element in this matrix would be multiplied with this scalar. So 7 times minus 5, 7 times 6, 7 times 2, that's your first new column. Then 7 times 3, 7 times negative 8, and 7 times 9. So now you may just write the final thing. So 7 5s are 35. So this is minus 35. This is 21. 7 6 are 42. This is 14. 8 times 7 is 56, so minus 56. And finally 9 times 7, that is 63. So that's your matrix 7 times 8. We've used the concept of scalar multiplication. Now let's go to this one. 6 times b. So now I'm going to do it little direct since you already know the method. So 6 times b means each element in this matrix is multiplied with 6. So 6 times 5, 6 times 4, that's the first column. 6 times 5, 6 times negative 4, 6 times negative 7. So let's just simplify. So 12 times 6 is same as 72. This is 30, this is 24. Again 30, negative 24 and negative 42. So we have got both the matrices. The order does not change. So again 3 cross 2, 3 cross 2. Now final step to combine them both by subtracting. So 7a I'm going to write first. All the elements here. And then I'm going to subtract from this 7a 3b. So I'm going to write again the elements of 72, 30, 24, again 30, negative 24, negative 42. Now when we are subtracting, the rule is very simple, quite a straightforward rule: subtract the corresponding elements. So that means the first column would be negative 35, negative 72. So this negative comes for each element, the sign changes because of subtraction. 42 minus 30, 14 minus 20. So that's first column. Let's write second one. 21 minus 30, negative 56 plus 24. Now why I've written plus? Because there are 2 times negative. So it changes to positive. 63 again plus 42. The final matrix, I don't have space here, so I'm going to write the final answer here. Let's do the final step. So 35 with 72 would give you negative 107. Here you will get a 12. Here you will get a negative 10. Let's do here as well. So 30 minus 21, that's a negative 9. Then you have 56 minus 24. We have to take care of the sign also. So 56, bigger number as negative sign. This is going to be negative 32. Last but not the least, 63 plus 42. So that gives you 105. So this is the final matrix, which is your answer. So I hope you have understood how multi-step operations are done, where you have a combination of scalar multiplication or addition and subtraction with it. Let's now solve some more questions. Here, example 4 are solved for you. You can use this slide to revise the concepts that we have covered today. First, I'll go through the solved ones. These are pretty easy. So we'll use the multi-step operations. Matrix A and B are given to you. You need to find 2A plus 3B. So step 1, you'll multiply matrix A. So there's a mistake here in typing. I'm just going to correct it. So they're asking you actually 2B and 3A. So they have calculated 2B here. 2B will be each element of this matrix. B multiplied with 2. So 1 multiplied with 2 would give you 2. 3 multiplied with 2 would give you 6. 4 multiplied with 2 will give you 8. 7 multiplied with 2 will give you 14. So that's 2B matrix. Now for 3A, each element of matrix A will be multiplied with 3. So 3 times 9 is 27. 3 times 1 is 3. 3 times 1 is 3 again. 3 times 2 is 6. So 3A and 2B are done. First, final step is to add them up. So after you finished with the scalar multiplication, just add them up. So again, for addition, you'll add element wise. 2 plus 27, 29. 6 plus 3, 9. 8 plus 3, 11, and 14 plus 6, 20. So that gives you the final answer for 3A plus 2B. Similarly, for example 4, now you are going to do scalar multiplication and subtraction. But here if you observe, the matrix C has 2 rows, 1 column, 2 cross 1. This is 1 row, 2 columns. They are of different dimensions. So because the dimensions are different, you cannot subtract the matrices, and there is no need to even do the scalar multiplication since they are of different orders. So we stop here. Now, perform the integrated operations if the matrix does not exist, write impossible. Is this having the same order? That's first thing we check. 2 cross 2, 2 cross 2. So same order, that means we can add them easily. So just add the elements: negative 2 with 1, 6 with negative 3, 0 with 9, 8 with negative 4, and then multiply whole result with 3. Answer will come out to be this. Next one, again the matrices are 2 rows, 1 column, so 2 cross 1 matrix, all are of same order, so we can do the operation nicely. First you are going to subtract them and then you add the result. So the answer would be this much. Please check your answers. And question number 8 is a word problem. We are going to now solve it nicely with all the steps. So let's do it in the next slide. Okay, let's solve this question now. Question number 8. It's an important question. Similar are going to come in your ministry exam. Current fashions buys shirts, jeans and shoes. So three quantities, shirts, jeans, shoes from a manufacturer and marks up to them and then sells them. The table shows the purchase price, which is nothing but the cost price, and selling price. So CPSP, this is what I've denoted. Two columns, three rows denoting the three um, items. So here definitely very easy to find. This is going to be the matrix. So for answer A, you will just write the matrix having the two rows and two columns. So this is actually the matrix, but if you read carefully, the matrix which is asked is only purchase price, means not both the columns but only the first column. So for this, the matrix would be 15, 25 and 30. So let me denote this matrix with CP. That's the cost price or purchase price. For B part, it is asking you the matrix for selling. So I'm going to denote by SP, the second column, which is 35, 55 and 85. So if you just observe, let's do a few observations before we move on to our answer. If you see, the shirt was purchased at $15 and sold at 35. Jeans was purchased at 25 and sold at 55. And shoes was purchased at $30 and sold at 85. So it is sold at a higher price. So there is some profit which is being made. So in the last question, you have to use matrix operation to find the profit on one shirt, one pair of jeans and one shoe. So very easy. You know the formula for profit. Profit is the difference between the selling price and the cost price. And definitely selling price is higher in every case. So there is going to be a profit. So what we can do, if we just subtract the two matrices we got in A and B part, we are going to get our answer. So 35 minus 15, 55 minus 25, and finally 85 minus 30 is going to be your profit matrix. So what do you get? You get $20 profit on one shirt. You get $30 profit on one pair of jeans, and you make $55 of profit on one pair of shoes. So what you did? You just did matrix subtraction to get your profit. Here, easy question. The point to remember here is that profit is selling price minus cost price, and to note that in this question selling price is more than cost price for each item. So with that, we have come to the end of today's session. It became actually a pretty long video, more than 30 minutes, but I'm sure in order to revise your concepts of addition and subtraction of matrices, you watch the video till end, and don't forget to like it if you found it useful. Throw in your comments and suggestions, and stay glued to my channel because coming up is the video for multiplication of matrices. Until then, this is Miss Ruchika signing off. Make sure you subscribe to the channel and hit that bell icon to receive updates of my upcoming videos. Bye students.